Hey everyone, welcome back to Best Bester. Today, we're going to explore an important concept in mathematics and computer science, the Fibonacci sequence. We will learn what the Fibonacci sequence is and how to implement it using both iterative and recursive methods in JavaScript. By the end of this video, you'll have a solid understanding of how to generate Fibonacci sequences. Let's dive in. First, let's understand what the Fibonacci sequence is. The Fibonacci sequence is a series of numbers where each number is the sum of the two preceding ones, usually starting with 0 and 1. So, the sequence goes 0, 1, 1, 2, 3, 5, 8, 13, and so on. Each number in the sequence is called a Fibonacci number. Let's start with the iterative approach. In this method, we use a loop to generate the Fibonacci sequence up to the nth term. In this function, we first check if the number is negative. If it is, we return null because the Fibonacci sequence is not defined for negative numbers. We initialize an array sequence with the first two Fibonacci numbers, 0 and 1. We then use a for loop to calculate the next Fibonacci numbers by adding the two preceding numbers and pushing the result into the sequence array. Finally, we return the sequence array up to the nth term. Now, let's look at the recursive approach. Recursion is a technique where a function calls itself to solve smaller instances of the same problem. For generating a sequence, we can use a helper function to build the sequence recursively. In the recursive function, we handle the negative number case first. We use a helper function with an optional sequence parameter, which defaults to the first two Fibonacci numbers. If number is less than or equal to the length of the sequence minus 1, we return the sequence array up to the nth term. Otherwise, we push the sum of the last two numbers in the sequence array and call the function recursively. This continues until the sequence is built up to the nth term. Let's look at a few examples to see how both solutions work for different values of number. For fib sequence 2, the output is a 0, 1, 1. For fib sequence 5, the output is a 0, 1, 1, 2, 3, 5. For fib sequence 10, the output is a 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55. We get the same results with the recursive approach. For fib sequence recursive 2, the output is a 0, 1, 1. For fib sequence recursive 5, the output is a 0, 1, 1, 2, 3, 5. For fib sequence recursive 10, the output is a 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55. Both approaches have their pros and cons. The iterative method is usually more efficient in terms of time and space complexity because it doesn't involve the overhead of multiple function calls. The recursive method, however, is more elegant and can be easier to understand. But it can be inefficient for larger values of number due to repeated calculations. For larger values, we can optimize the recursive solution using techniques like memoization, which we'll cover in another video. That's it for today's video. We learned about the Fibonacci sequence and implemented two different solutions in JavaScript to generate the sequence up to the nth term. If you found this video helpful, please give it a thumbs up and subscribe for more programming tutorials. If you have any questions or suggestions for future topics, leave a comment below. Thanks for watching, and happy coding!